Well, it's a pleasure to be here today, and it's great to be able to tell such a large audience about ViBE. As Tony mentioned, it's quite an innovative product. It's unique in the market, and it was developed in country and is well suited to local conditions. So, simply put, ViBE is about bandwidth enhancement. So it's designed to boost the performance and increase the quality of your internet and WAN connections. So it also enhances IP voice services and delivers a 5-fold increase in IP voice call capacity. In addition, it also provides superior call quality, and I'll go into that a bit more later on. So in terms of IP voice, the 5-fold increase in call capacity is achieved whilst maintaining the raw quality of the voice codec. I'm sorry if I'm going a bit complex here. But in real terms, the MOS score that we achieve with ViBE is around 4.4. So to put that into perspective, telepresence achieves a MOS score of around about 5, and ISDN typically achieves a MOS score of around about 4.2, with anything above 4 being considered good call quality. So whilst it achieves these high quality scores, we can also transport a lot more IP voice over the data circuit, 5-fold. Once we hit our optimum point of transporting 15 calls. So how do we increase the call capacity so much without actually compressing the voice data? So if we have a look here, we can see that in a G729 voice packet, we have about 8K of voice data payload, and the rest of it is actually overhead, which is associated with transporting the voice data within an Ethernet packet. When we then move to other technologies for transportation like ATM, this actually gets even worse because we have to then put this data into a frame. So in the case of 4 G729 IP voice packets, we can see here we're actually using a lot of space. But what ViBE does is it actually takes the voice data payloads out of the packets and then repackages them into one ViBE packet. So what that means is that as we add more and more voice calls to the data circuit, we get more and more efficient voice transport. In addition, ViBE also offers byte-level QoS. So it differs from packet-level QoS that everyone's used to, and there's a couple of animations coming up to describe this, or at least illustrate it. But certainly in terms of cloud applications, or that nasty word we shouldn't talk about, for things like Telnet, Citrix, remote desktop, SQL, as well as your UDP applications that can't afford to drop any packets because you end up with a disturbed customer experience, ViBE will actually ensure that that data gets through in real time. So that means it's not going to hit any QoS buffers within your network. So, thank you. So if we have a look here, this illustration actually shows what happens with the normal QoS queue. So because it can't really determine the packet size, the packets just go through in order of what the QoS priority queue is. So if we have a look there, we're showing a voice queue, and that induces a thing called jitter, because the voice packets aren't actually transferring in real time. So that simulation with the large packets down the bottom, they could have been emails, it could have been a video, competing for space with that voice traffic. So with ViBE, we actually are able to deliver those smaller packets in real time by using our byte-level QoS mechanism. So you can see here with our voice payload, that data is always getting through, whilst we're causing minimal impact to other data types. In fact, you wouldn't even notice the holding back of the larger packets in that circumstance. So in terms of actual jitter reduction, this graph here actually shows that on a 288K ADSL link, with 3 calls, we're experiencing 100 milliseconds of jitter. Now, in technical terms, what that means is that you may, if you're a really good listener or if you have sensitive hearing, you may be able to detect that level of jitter. However, for most people, that would be a pretty standard call. They wouldn't be able to tell that you're on using IP voice services or if you're using plain old telephone system. Highlights here are transporting 10 calls with ViBE over the same link. We're actually only inducing 1 millisecond of jitter, right? So that's a 100-fold decrease in jitter, whilst transporting, in this case, 3 times the amount of calls. So you can see in the earlier animations, the way that the byte level quads actually allowed the voice traffic to travel in real time, which then induced less jitter on the link, which means that you have a much higher quality voice call. So that then, in turn, shows how we achieve those MOS scores that we illustrated earlier on to give that high-quality voice experience. So in addition to what we can do in terms of IP voice and enabling services like SIP trunking or also inter-site IP voice connections, we also have some bandwidth enhancement technologies. Now, the first bandwidth enhancement technology that we've felt we've pioneered in this market is what we call rain mode. So it's analogous to rain mode and in particular disk mirroring. So what we can do is we can take 2 data links and we can send identical data across the 2 links. So what that means is if link A drops a packet, it's almost certain that link B will let the packet traverse. So once again, if we come back to the example of using, for example, Citrix, which requires a very small amount of bandwidth, but it doesn't like to have packets dropped, it means that from a user experience, I get a much more LAN-like experience because those packets aren't being dropped between the 2 links. We also have a feature called bandwidth stacking. Now, once again, it's analogous to link bonding that's available out there, but it works in a much different fashion. Because ViBE always works through a head-end device within a data center service provider or head office, what we're able to do is actually monitor those links a lot more closely. So with our bandwidth stacking, if we take links of varying capacities, and even up to a degree varying latencies, we can actually address it as a single virtual link, which means that in areas with poor link availability, or if you want to simply use lower cost bandwidth services to deliver connectivity to your office, ViBE enables this without actually having a massive overhead in the link performance. Also, with our bandwidth stacking technology, we don't suffer from a thing called out-of-order packets, which with technologies like MLPPP can really cause a lot of issues when you're trying to use link bonding in a commercial environment. Another mechanism we have is stacked rain mode. So you can probably guess that that's a combination of the past 2 bandwidth stacking methods. So stacked rain mode, you use a minimum of 4 data circuits to first of all duplicate the data that you're sending across the links, but also to stack up the data. So you get an increase in speed as well as data circuit quality. We also have active-passive mode. So the reason why we have this is that even with a lot of the next generation services, such as fiber to the cabinet, we still don't have the reliability and uptime as some of the traditional services. So really, I see it as the holy grail of uptime. So with something like active-passive mode, we could use stacked rain mode for the majority of our data use, and we'll probably get a good amount of uptime out of it. But for those 2 hours every year that all of those circuits fail, active-passive mode would allow us to fail over, for example, to ISDN services. Now, you can ask why you'd want to do that, but when we look at ViBE, I could deploy an ISDN2 circuit for peanuts per month, and then instead of having that failover supporting just 2 simultaneous calls, it would actually support with ViBE 10 simultaneous calls. So suddenly we've got a service to deliver the voice uptime we require to keep our business going, but we can also take advantage of stacking low-cost bandwidth types. In terms of voice and data security, because ViBE is a tunnel technology, we can encrypt all the data that sits within that tunnel. So it means that if we are deploying SIP services or if we have concerns over security, we can encrypt all the traffic that goes either between the sites or back to the data center or into the service provider. So in terms of deployment, we can see here there's quite a few different deployment models for it. ViBE works quite well in an MPLS environment because it allows you to use your bandwidth much more efficiently. It also ensures that if you're using different physical mediums underneath your MPLS network, that you are going to get a higher grade of quality, even if they are low-cost transport mechanisms like ADSL. It also means that we can haul temporary sites that are delivered by, say, 3G, 4G services back over the internet into our head office and in our ViBE infrastructure. One of the other key things about ViBE is we can take out and swap any part of the underlying infrastructure without having to go through and readdress all of the sites within our network. Because the IP addressing across the ViBE multi-site network is attached to the virtual tunnels themselves, any change in underlying infrastructure doesn't actually change the overall layout of your corporate network. So I'll briefly touch on the product range, and this is always exciting to produce something with blinky lights, especially when you're doing it yourself locally. So our head-end device is the 600 series, which sits within the service provider network, and you can be quite confident that when you are using ViBE that it is well engineered. These devices have dual power supplies, and they also support N+1 resiliency. So we can guarantee that there's going to be uptime within the data center. When we move down to the client devices, one unit that we are incredibly proud of is our dual DSL device, which is a really good enabler for small and medium businesses, but also for branch offices. In that, it's got two ADSL connections integrated in, where we can use our bandwidth stacking or rain mode features. It then really allows us to drive SIP trunking services into these companies as well. We can also support the ISDN failover feature that I discussed earlier through the Ethernet port by using an ISDN router off the back of that.